This is class lecture for Chapter 4. This week we are exploring data with graphs. This is Part 1 lecture. Our Part 1 lecture is only going to focus on looking at the different types of graphs, explaining when to use each one. Part 2 class lecture is going to go through SPSS and showing you how to create the different graphs in SPSS. So let's go ahead and get started. So this week we're looking at histograms, bar charts, and scatter plots. So the histogram is a graphical representation of continuous data. Remember, we talked about continuous and categorical data. Our continuous data is our numerical data, our quantitative data. This is where we're looking at numbers. So notice here is a picture of a histogram right here, and this is actually a picture of the data that is here. So notice we have age. We're looking at age, and we're looking at the frequency of age. So we're looking at, for example, how many 18-year-olds are in this data set? We have 2. How many 19-year-olds in this data set? We have 2. Oops. Sorry about that. If we go down and look further, how many 25-year-olds we have in this data set? We have 9. Okay? It gives you the percentage, of each age. So for instance, we have 4% of our participants are 18. Okay? So our valid percent and our cumulative percent. So let's look at our histogram. So notice that the first 4 bars are each 2 units tall. And this is because the first 4 numbers in the table that we just looked at, 18, 19, 20, and 21, each occur 2 times in the data set. So let's go back and look at the table. So again, we have 2 participants who are 18, 2 who are 19, 2 who are 20, and 2 who are 21. And this is what our histogram is showing. So our participants who fall within this age range right here are all, there's 2 of each. So notice that the tallest bar here is 9 units tall. Okay, about 9 units tall, and this is because the number 25 occurs 9 times in the data set. Remember, we looked at that just now. So it occurs 9 times in the data set, our 25-year-olds. So in addition to understanding the variable using descriptive statistics, remember we talked about mean, mode, median, etc. The histogram provides further insight into the characteristics of a continuous variable. Remember, a picture is indeed worth 1,000 words. So in addition to our histogram, one of the characteristics that a histogram can hold is a normal distribution. So sometimes this is called a normal curve, sometimes it's called a bell curve because of its shape. So the normal curve is derived from the same data source as the bar chart. You can think of this as the normal curve. It's almost like a smoothed out version of the bar chart. So let's look at this particular example in context, and let's see if a normal distribution makes a little more sense. So, for example, if we were to measure the height of 100 randomly selected people, we would expect to find that most people are moderate height, which would constitute the tallness in the middle of the normal curve. So the majority of people would have a moderate height. We would also expect to find a few exceptionally short people and about the same of exceptionally tall people. And this would account for the tapering off seen on the left and the right tails of the normal curve. This phenomenon of the bell-shaped distribution is so common that it's referred to as a normal distribution. And when assessing a histogram for normality, we are expecting the normal curve for symmetry. So again, looking at our histogram, this is our normal curve right here, where we said that there's going to be a few people here who are a little younger, going back to our age histogram. There's a few people here who are a little older, and the majority of the people fall within this middle age range. So if we were to slice this normal curve vertically down in the middle, the half of the normal curve should be a mirror image of the right half. And so when you are inspecting a histogram with a normal curve, we expect to see some variations, some asymmetry among the heights of the bars. But if you're looking to see if it is a normal curve, you're looking for that symmetry. How symmetrical is it, the right side and the left side? Or do they have a mirror image? Again, it doesn't have to be perfect, because right here it's not perfect, but the majority of our data do tend to fall underneath this normal curve here. So this data would be considered normal. So again, to assess, inspect the normal curve for symmetry. Now sometimes, of course, in real life, data is not perfect. Data will not always fall within that normal range. There will not always be a normal curve. Data will not always be normal. So sometimes our data are skewed. We have skewed distributions. So depending on the distribution of the data within the variable, the histogram may be skewed, meaning that the distribution might be tilted a little bit. So let's look and see exactly what skewed distributions look like. So we can have what's called a left skew, a negative left skew distribution. So looking at this histogram right here, notice that most of the data are on the right, between about 150 and 300. This is where most of our data fall. And there's a small scattering of lower scores here, under 100, forcing the left tail of the curve to be extended out. Now these few low values that substantially depart from the majority of the data are referred to as outliers. So notice this is a way, these values right here, there's just a few of them. And so these are called outliers because notice they're not with the majority of our data. It's kind of they're off to the left, all by themselves. So typically once you graph your data, outliers can easily be seen. So notice here, you easily notice these outliers. So, because our outliers are to the left, which makes our tail come down to the left, it is skewed left or negative skewed. So immediately, I guess when you look at this, you might think, oh, right skewed because the majority of our data fall on the right side of our histogram, but no, we're actually looking to see where does that tail fall. So if that tail falls on the left, it's going to be left skewed or negatively skewed. So outliers are not always negative though. So let's look at this next histogram. This next histogram is actually a mirror image of our last histogram. Now these outliers are scattered to the right here. So this distribution would be referred to as a right skewed, skewed right, or positively skewed. So we looked at histograms, bar charts, or we can call this, you might see it sometimes it's called a bar graph or a bar chart. Both are the same, it's just different terminology, means the same thing. So a bar graph or a bar chart, let's say our textbook calls it a bar chart, so we're going to use a bar chart. It's a graphical display of data using bars of different heights. So let's look at this particular example. So imagine you did a survey of your friends to find out which kind of movie they liked best. So we see that 4 of our friends liked comedy the best, 5 liked action, 6 prefer romance, 1 drama, and 4 of your friends prefer science fiction. So we can actually create a bar chart that looks like this, that shows their favorite type of movie. And a bar chart is a good visual, it's a good way to instantly see what your data are showing. So we can see, it's a really good way to show the relative sizes, so we can easily see with this bar chart what type of movie is most liked. Our romance is most liked. Sorry about the typo here. See that it's missing an E. We can see which one is which is least liked, which is our drama. Okay? So we can use bar charts to show relative sizes of many things. We can see what type of car people like, how many customers a shop has on different days, so on and so forth. So we can also, here's another example. Let's look and see, if you had a survey and you're looking to see what people's most popular fruit is. So we have a survey here that was given to 145 people, and they revealed their favorite fruit. Okay, this is the fruit, and this is how many people chose this as their favorite fruit. So 35 people chose apple as their favorite fruit, and